Tamarillo, scientifically identified as Solanum betaceum, represents one of the most distinctive domesticated fruits of the Andean region, particularly embedded in agricultural traditions of Peru, Ecuador and northern Bolivia. While its modern identity is commercially associated with New Zealand, its true legacy is indigenous and pre-Columbian, forming part of the structured high-altitude shrub cultivation systems that sustained local food security. The structure of the Tamarillo plant separates it from the conventional tomato not only in physiology but also in ecological identity. Tamarillo belongs to woody perennial shrubs, reaching up to 3 meters in height, often forming a multi-stemmed canopy. The stems exhibit green pigmentation even into maturity, reflecting persistent photosynthetic function. Its fruits display elongated oval morphology, ranging in skin colors from bright orange to crimson red and burgundy purple. Unlike common tomatoes, Tamarillo contains a distinctly acidic pulp, partitioned into color zones, orange-red outer walls, deep amber gelatinous seed chambers and anthracene and dense epidermal tissue. Historically, Tamarillo cultivation traces into terrace farming networks, where elevation stabilized temperature and frost exposure. Indigenous agricultural terracing allowed controlled irrigation, often fed from meltwater systems. Ethnobotanical recordings suggest that Tamarillo pulp was dried for storage and used alongside ground maize or amaranth flour. The expansion beyond the Andes occurred through post-16th century Spanish movements, though mass distribution emerged much later. The most significant shift occurred in the mid-20th century when New Zealand horticultural institutions began refining Tamarillo through selective breeding. The objective was to remove excessive bitterness, stabilize uniform fruit size and strengthen export shelf life. Red-fleshed commercial cultivars, most notably the red Ecuadorian line, were refined into thinner-skinned, milder variants. Despite these changes, the Tamarillo retained high acidity. This acidity is not merely taste, it represents biochemical resistance. Anthocyanin concentration in the skin contributes to microbial defense, including inhibition of fungal intrusion. Nutritionally, Tamarillo presents elevated vitamin C and provitamin A levels relative to conventional tomato. Its mineral profile includes iron, potassium and manganese, while seed fraction contains polyunsaturated oils. The pulp contains phenolic compounds studied for antioxidant behavior, though commercial science remains ongoing. While its flavor resembles tomato superficially, chemical profiling aligns Tamarillo closer to passionfruit in aromatic complexity. Volatile ester compounds and aldehydes contribute to a layered acidity not present in standard Solanaceae fruit. This complexity led to culinary integration beyond raw eating. Tamarillo chutneys, preserves, fermented beverages and reduction sauces became signature applications. New Zealand successfully positioned the Tamarillo into export channels. However, commercial challenges persist, including temperature sensitivity, perishability, bruising susceptibility, and requirement for specialized protective packaging. Traditional cardboard carriers were replaced with molded support crates that prevent contact abrasion. Modified atmosphere packaging is under experimental evaluation to reduce post-harvest respiration. Agronomically, Tamarillo propagates primarily through cuttings rather than seed to maintain uniform genetic lines. Root development of cloned cuttings increases fruit yield consistency and allows orchards to maintain standardized ripening cycles. Seeds, however, remain viable for varietal experimentation. The fruit's global footprint expanded into Southeast Asia, where its acidic pulp became integrated into savory cooking, specifically pairing with fish-based dishes. In Brazil and Colombia, Tamarillo juice processing accelerated, incorporating pulp into commercial beverage systems. While it has modern global positioning, Tamarillo remains tied to cultural symbolism. In Andean agricultural practice, fruit-bearing shrubs represented sustainability and household resilience. Tamarillo appears in folklore narratives referencing survival crop systems that persisted regardless of political or ecological instability. Commercial valuation of Tamarillo continues to climb due to its visual distinctiveness and flavor niche. Emerging culinary disciplines explore dehydration, freeze-drying, candied infusion, purees for sorbets, and incorporation into experimental gastronomy plates. From a botanical perspective, Tamarillo is the biological bridge between common tomato and tropical berry structures. From a cultural standpoint, Tamarillo is a continuum of Andean agrarian identity. From a commercial standpoint, it is a developing export economy. Its flavor is not universal, yet that is precisely why it endures. Tamarillo is unmistakably itself.